Swinburne University of Technology.
My name's Adam Taylor. I'm a PhD student with the Centre for Microphotonics, and I'm in my fourth year of PhD, just in the process of writing up my thesis at the moment. So the title of my project is the photothermal properties of gold nanorods and their applications to multi-layered optical data storage. Some of the really technological hurdles we're really trying to surmount here is data storage, or in terms of making next generation computers and processors. Standard techniques can make things only so small, and if you want to fit either more data onto a chip or more resistors onto a chip, faster processors and smaller processors, then you really need to get to that really small super scale. And when you take metal down to a very, very small scale, you can start doing some really interesting physics with it. And so we can sort of look at making next generation data storage disks, interesting displays, or looking actually at the fundamental physics that happens with these things. The issue at the moment is that we're reaching sort of capacity limits on our traditional sort of our disks, our data storage medium. At the moment, sort of Blu-ray is about 50 gig, and so we want to sort of the next step up, and that is into the terabyte sort of regime. And so it's in the range of that 50 to 100 terabytes onto a single disk that we're really looking to push the boundaries of. Take your standard CD, and instead of putting a dye on there, we can actually start putting these nanoparticles on there, very small particles of gold and silver. Again, 10,000th of the width of the hair on your head. These particles, but very precisely in very particular shapes. And so we can actually use the electron lithography machine, and so I can record data and record patterns into these multi-layer structures. In doing that, I can evaluate how these things work as a multi-layer data storage medium, and then I can also examine the fundamental physics, the underlying physics of how these nanoparticles, how they interact with a laser. Because we're looking at sort of processing these samples to make very, very ultra small features on them, we need them to be very clean. We have these things called the clean room suits, or affectionately known as bunny suits, because we look like bunnies. If you imagine like the dust in your house, about 70% of it is actually sort of human, human skin and hair and everything like that. So we actually have these suits to protect us from that. What we perceive as being clean, it can be actually, you put it on your microscope and it's covered in dirt. What really motivates me is that we're at that cutting edge that we're actually solving some of the world's big problems here. In the Centre for Nanofabrication, which we're currently sitting, Swinburne has given us this amazing laboratory to work in and make my discoveries, and that really puts us at advantage compared to other universities, because not every university has the access to this quality lab. This is one of the best in Australia. Some of the strongest advice that I can sort of give is to really understand your research field, and also understand sort of what you want to do afterwards. And I've always been interested in a career in research, and so for me a PhD has been a stepping stone to get that. People sometimes fall into the trap where they go through their university sort of degree and they're doing one degree after the other, and rather than sort of go and sort of think about, okay, what do I need to do? I'll just do the next thing in the path, and you get to the point where the PhD is the last next thing you can do. So the end goal shouldn't be to get a PhD, because you get a PhD and then work out now what. You'll be caught at the end of it. So if you see, okay, this is finally what I want to do, and the PhD is just a step in that path.
This has been a Swinburne production.